Okay, good evening everyone. Welcome to a beautiful late winter evening in the eastern desert of California. My name is Mike Jerry and starting a few minutes early tonight, but I'm ready to go, so why not? Okay, let me make sure I got that set up. Very good. Okay, so kind of doing a more or less a wing at night. I did make a bit of a list of us to go through tonight, but you know, we'll see how it goes. Let me turn off the test pattern here, and we'll start off by showing you my setup of what's going to be bringing us all the images tonight, which is going to be an 8-inch Schmidt-Cassegrain telescope up here with Starzona Hyperstar stuck in the front and a camera in front of that, and that's going to be swinging around the sky on an AM5 mount, showing us everything. Hey Daryl, how's things in Texas tonight? We're going to be using this mount tonight, and it's on my cinder block pier, and I'm on it sitting at a table behind that's set up behind all this. But this is the setup that's going to be bringing us the images tonight, and the Hyperstar stuck on the front of this thing dramatically speeds up the scope, which is f10 in focal ratio natively, and this speeds it up to 25 times faster than that at f19. So it brings us really nice images pretty quickly. So that's what's going to be happening with that. Okay, now I actually started off with I used CAF as my focusing star, which is the brightest low star in Cassiopeia, and right next door was Caroline's Rose. So I figured I would just take a quick... Ooh, what are you doing down here? That's interesting. I don't know how you got loose. Alright, Caroline's Rose, which is a nice little cluster. This is still all set up from last night. So let's get this fixed. There we are. Oh, and I forgot the flats. Okay, the flat is in place. Let's clear this, because the flat will greatly even off our light. Hey Michael, how are things? I think you're all cloudy out there on the East Coast, it looked like from my satellite imagery. Cloudy 53 in Texas. Okay, well, that's not too bad, Daryl. Hey Ron, thanks for coming tonight. Just kind of getting set up here a couple minutes early, but let's see what we can see now. This should come in much better. Okay, yeah, that still looks pretty good. Let's rebalance the colors and redo the stretch so that it makes a little more sense. And we should be able to see this star cluster quite nicely. This is Caroline's Rose. Yeah, 40 in Virginia. Yeah, you used to talk about warm. We're actually headed for some warm too. They're talking maybe 80 on Monday here. It's supposed to, today was like in the mid 60s, and it's supposed to be the coldest day for the next week. Our extended forecast is saying it's basically going to be 70 plus for the next week, possibly 80 on Sunday, Monday. So a little bit of early spring weather showing up for us here. Okay, so this is Caroline's Rose, or Ghost Cluster, Star Mist Cluster, Herschel Spiral Cluster, Crab Cluster, or Screaming Skull Cluster. I guess depending on the instrument that they were using to look at this thing, it looked like a whole bunch of different things. Yes, this is named after Caroline. It is true. And yes, it would not surprise me at all that she's the one who discovered it. In fact, let's bring up our Wikipedia here and NGC space, no, all, copy, 7789, I believe, open star cluster in Cassiopeia. It's also called Caroline's Haystack, or the White Rose Cluster. It was discovered by Caroline, as you called it, in 1783. Oh, good evening, Myra. Well, I said, yeah, Professor Moth did not let me know that you guys were going to be going to have some people here, so that's great. I'm glad you're here. All are welcome. We're going to see a number of different things tonight. It's a white rose cluster, swirling patterns. The cluster, when seen visually, the loops of stars in dark lanes look like the swirling pattern of rose petals as seen from above. I've never been able to actually see that, but, well, again, what we see with our modern cameras and what they were seeing with their optical equipment 300 years ago is quite different. I'm going to try backing off the stretch a little bit, see if we can actually see what they're talking about. I mean, I see dark lanes and little patterns in there, but I don't know. I think they were practicing averted imagination to come up with the rose, but they probably looked at it a lot longer than we're going to tonight. Let's see, other designations, distance, about 2,300, 2,400 light years away is this. And do they say how many stars are in this? No, they don't really say how many stars are in this, but it looks like a nice bunch. They do call it an open cluster. It's not considered a globular cluster, but it's because it doesn't have a dense core at its center, but it's still a pretty dense little cluster of stars. So it's a pretty cool thing. Oh, good evening, Evadny? I'm not sure how to pronounce that. Evadny, I'm sorry if I'm pronouncing that wrong, but welcome. I'm glad you're here. In the eyepiece, the rose definitely... You know, Michael, it's been so long since I've looked at this through an eyepiece. Actually, it's been so long since I've looked through an eyepiece, period, that I just don't even remember that. But I'm sure I've looked at this through an eyepiece before. Let me get the background music going here. And let me know if my volume levels are okay. You can hear me just fine over the music. I think I have things dialed in pretty well at this point, but so yes, this is a very pretty cluster, and so I can show you guys where this is. Most people can find Cassiopeia in the sky right now tonight, especially those of you in Professor Moth's class who are on the West Coast, can look up pretty high in the sky in the northwestern sky, and you'll see this almost upside down lazy W in the sky, and this cluster is right off the end of it down here, just below it. And it's a pretty cool binocular target. So if you've got clear skies where you are, and I don't think you guys up in the Bay Area do. Evadny is correct. Oh, good. I'm glad. And so yeah, if you got clear skies, I don't think you in the Bay Area do, because there are clouds that are going to be dropping down on us, down on me sometime tomorrow, and I think they're already crossing through your skies tonight. But yeah, it's a very pretty cluster. And because it's a star cluster, we won't spend much time in it. We don't really have to, because star clusters resolve pretty quickly. Actually, it's higher up than I thought. Could even do. Yeah, I think these are all just Wizard, Cave, these are all hydrogen, which is better with a... oh, there's a reflection nebula. How big is it? 15 by 10. Okay. Cepheus? Where is Cepheus? Are you going to be high enough? Where are you? Oh, there you are. Yeah, actually. This would be... we could do this one. It's right inside Cepheus, so... yeah. We're going to try that one next. Okay, cool. We'll do another minute or two on this. And then we'll move on and we'll try a reflection nebula. Reflection nebula works really nice. Brighten this up a titch. Maybe a titch more. Get some of that star color going. It's a pretty little cluster. Discovered by Caroline Herschel, sister of William Herschel, who discovered a whole lot of stuff in the sky. Half the stuff in the sky he discovered back in the late 18th century. Alright, let's go ahead and go to... so that's Caroline's Rose. Let's go ahead and go to this other reflection nebula, which is lower, but not too low for us. Yeah, I think that should be just fine. Okay, we're going to get right out. I don't think Stellarium even has a picture of this. It doesn't. So we will create our own picture. Okay, it's small, but it shouldn't be too small. It should work for us. Okay, that's, yes, 1 minute 53 gain, that's all good. That's all good. And yeah, I didn't change the profile, so I don't have to reload the flat. So let's take a look at this reflection nebula. Yeah, I don't think this will even have a an entry in Wikipedia. So we will see. Oh, thanks for whoever gave me the thumbs up. Much appreciated for the YouTube love. I'm not sure this even has a name. VDB. It's a decent size though, so hopefully we'll be able to see something pretty good. Yeah, there's something glowing in the middle there. Oop, that's a little too much. Bring you in here somewhere. Oh, it's there, but it is faint. Yeah, this is very, very faint. I'm going to have to stretch the heck out of this to get you guys to see any of this, but it's very faint. It's in there. It's very faint blue reflection nebula that is surrounded by some other reddish, looks like hydrogen stuff out here, but just a little bit of faint blue reflection in here. Very faint though. I don't think we're going to spend much time on it. It's a little too faint for what we want to be doing tonight. But you can just sort of see the contrasting colors. The blue of the reflection nebula, which is reflecting the light of stars, probably this star, and the reddish glow the reddish brownish glow over here of what is probably emission nebula. And the difference between them is reflection nebula is simply reflecting the full spectrum light of a star near it, probably this star here. It's just reflecting the light of this. Emission nebula is actually being irradiated. Typically the ultraviolet light from the star will irradiate the gas and cause it to emit its own light, in this case in the hydrogen band, which is why it's a bit reddish. So, two of the three kinds of nebula. And actually, there's probably... the third kind is dark nebula, which tends to block light. And so we could actually be seeing some of that here, with some of this structure and some of this here where it blocks out the background star field. All this in here could be dark nebula. In fact, let's open up the annotation and see what it has to say. Yeah, so it says there's some dark nebula. It calls all of this the dark nebula and all of this here dark nebula. So, yeah, so that's what it is. And this is an SH2, which means it's in the Sharpless catalog. And the Sharpless catalog has a lot of emission nebula in it. So, and the DN is a dark nebula LDN catalog. So, anyway, we are seeing definitely all three kinds of nebulae in here. Michael wants to see 4236. Well, sure, we can do that. We'll do a few minutes on this, but it's very faint, but there's some pretty star color in this. And I like the colors of the nebula itself. We got satellites trying to bomb through here, which I'm not going to worry about because it's not going to interfere with our actual object. Got to bring this over a little bit more. Risk of overstretching it, pushing my luck, brighten it up a little more so you guys can see it a little bit better. You can definitely see the color contrast now between them. This is a very faint example of both kinds of nebulae. Last time with the dual band filter in, we got some really nice big bright red nebulosity that we were looking at. This one's a lot more subtle, but nice star color around it. Had all three types of nebulae, so it's pretty colorful, if a bit faint. Hey, Fantasy. Everything is still a go. The only way it's going to get canceled is through is if weather calls it off. But yeah, everything is still a go right now. Yeah, I really like the star colors in here too. Lots of yellow, older, cooler stars, and young, hot blue, white stars in the picture, and a lot of just regular old run-of-the-mill stars as well. So, kind of colorful. think we'll finish this sub up and go check out Michael's galaxy. 4236, he says. 4236. Oh, you're gonna make me flip over the meridian, are you? Boy, actually. Yeah, you know what? That's too low right now. I had actually planned on doing M81 and M97 tonight. So what we're going to do is I'm going to add yours to this list. I'm going to add yours to my list for tonight. And edit list. Add object. Yeah, see, Caldwell 3. And so we will do it later tonight, but it'll be at the end of the night because this is going to have to rise a whole bunch before I can get there. But, in fact, we'll give it its blue circle, save, highlight all, blink. Now it has this blue circle too, so we'll do all three of these a bit later on. Cool. Well, it'll be good to see you there. I will definitely be there. So, yeah, if you show up, we'll get to meet. So that'll be pretty cool. Okay. Let's go back over here to this side where we are at. And so we're currently on this one here. Well, since we're going to put Michael's galaxy off for a bit, we'll spend another couple of minutes. I'll go 10 minutes on this. I'll get a total of 10 minutes on it. A little more contrast on that. Unfortunately, this is such a small, subtle little object that I don't even have. There isn't even going to be a Wikipedia entry on it, so it's, can't really tell you much about it other than what I've said already. Not sure how far away it is. Okay, there is our 10th sub right there. Kind of a surprisingly fun little object. Let's move on to our next, which is going to be Ghost. So this is going to be, again, both kinds of nebulae. One is going to be a reflection and one is going to be an emission. And we're going to have a really bright star that's creating all the energy for those things. It's going to be right at the central star of Cassiopeia, called Navi. obviously is Navi right there. And this one's going to be a bit subtle again, especially without any filters. But I think it'll be a pretty cool thing to look at. It'll be brighter than the last thing we were at, though. Typically called the Ghost of Cassiopeia, although they call it YCAS. Actually, I think that might be, is that Gamma? I think it might be the symbol for Gamma Cassiopeia. Not sure. Anyway, IC59 and IC63. So it's going to be both kinds of nebula here again, an emission and a Cylindropuntaceous. Good evening yourself. It's the Dark Sky Festival in Borrego, Joshua, or somewhere else. So I posted, but can't recall which desert I was in at the time. The Dark Sky Festival that Fantasy is talking about is actually the one in Death Valley, up here in my neck of the woods. And it's going to be the third weekend in February. Okay. Bring you there. Bring you here. There we go. We're just getting little bits of them already in here. There they both are, the blue and the red. Both of them are being powered by the big, powerful Navi. Let's see. 63. Hmm. 63 and 59 don't seem to want to come up. Do I have a AV5? Don't seem to be able to. Let's see what this is. Sharpless 185. Okay, the massive star Gamma Cassiopeia. Okay, it's Gamma. On the massive star Gamma Cassiopeia in the northern north, it was included in the second catalog of H2 regions. So this is also Sharpless 185. Okay, so this is about 10,500 light years away. Now the region is surrounded by a dust shell and displays several infrared point sources that are characteristics of young stellar objects. This hydrogen-2 region includes the reflection and emission nebulae, IC59 and IC63, both of which we're looking at now. Both nebulae have a cometary shape, with IC63 being the brighter of the two. The difference in appearance between the two nebulae is a consequence of their physical distance from Gamma Cassiopeia. IC63 displays a well-defined horizontal front, while this is lacking in IC59. The nebulae are the closest photodissociation regions to the Sun. Photodissociation regions. This was discovered by German astronomer Max Wolf in 1893. From the perspective of Earth, IC59 is positioned in front of Gamma Cassiopeia, and the closest tip to the star is located at a separation of 13.5 light years. It is a photodissociation region that is being sculpted by Gamma Cassiopeia. Light from the star is being scattered from the nebula at an angle of 17 degrees toward the Earth. And so that's this one up here. Although the tip of the nebula has been considered the closest point to Gamma Cassiopeia, the western concave face is where the most intense UV radiation is being received. Hence, the tip may actually be further away from the star than the rest of the cloud. IC63 is somewhat dubbed the Ghost Nebula, or the Ghost of Cassiopeia. It was discovered by Max Wolf on the same night in 1893 and has been extensively studied. It spans an angular size of 10 arc minutes and is visible with a small telescope. From the perspective of Earth, it's positioned behind Gamma Cassiopeia, and the closest tip of the star is located at a separation of only 7.5 light years. It is a photodissociation region that is being sculpted by Gamma Cassiopeia. Photodissociation region. In astrophysics, photodissociation regions are predominantly neutral regions of the interstellar medium in which far ultraviolet photons strongly influence the gas chemistry and act as the most important source of heat. They occur in any region of interstellar gas that is dense and cold enough. Photodissociation are predominantly neutral regions of the interstellar medium in which far ultraviolet strongly influence the gas chemistry and act as the most important source of heat. Photodissociative. That's interesting. Hey, good evening, Don. The name is the Ghost of Cassiopeia. So the constellation Cassiopeia, which actually on the screen is spelled right here, Cassiopeia, Cassiopeia, which is again the lazy W, the lazy W in the sky, which looks a little upside down this time of year. But that's Cassiopeia there. And the middle star is Navi, or Gamma Cassiopeia. And these two nebulae, and there's that Gamma Cassiopeia, nice and big and bright. And these are the two nebulae that are on it, IC59 and IC63. One a blue reflection nebula, one an emission nebula. Hey, good evening, Mike. Mike number 3 is here. Don't know how I got so many mics, but I guess mics attract. I'll be doing field work then, but it sounds awesome. I used to go out to Little Blair Valley in Anza with the Oceanside Photo and Telescope Club. Yeah, Anza is a beautiful place, especially to do astronomy. Really nice dark skies and some great desert. Some beautiful stuff. Good, no problem, Myra. Let me know if you have any other questions. Happy to answer any questions you got. I am going to go start heating up my nice warm tea inside, so I'll be back in just a minute while we let this continue to build here. I think we're doing pretty good with it. Make a quick tweak adjustment there. Maybe move this in a little bit there. Yeah. Let this go for a couple minutes. I'll be right back. Alright, got that heating up. So Don, I'm assuming you are not broadcasting tonight. Looks like the whole East Coast north of Florida is all wiped out tonight. Don is a fellow broadcaster over at Night Skies Network. And I looked at the satellite imagery for tonight. It looked like the East Coast was pretty much wiped out over there. Ah, welcome, 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 Hernandez. Hope I'm pronouncing that right. Oh no, Rioberto, Hartnell student in Professor Moth's class. Okay, well you are there's at least 3 of you here tonight, so welcome, welcome. Oh, your Saturday night looks promising. Well, cool, because this is it for me for a while. Last night was great to be on NSN, and then tonight I'm doing this, and then, well, the good news is we're getting some really warm weather. It's a nice tropical flow, and we're going to be like 80 degrees Sunday and Monday. It's going to be beautiful here. Bad news is with the tropical flow comes the clouds, so not going to be very good astronomy. But so my weekend is definitely, I'll be watching you on Saturday night, because I certainly won't be able to be doing any myself. Yeah, there you go. That's a good list, Fantasy, of all the places in this area anyway. Certainly in Southern California, Southern and Central. Joshua Tree used to be amazing before Palm Springs light pollution. Yeah, all of Coachella Valley has really just exploded. Wonder Valley is still pretty cool, but you either got to drive a bit east or a bit north. Of course, then you have the base that's there too on the north side of Wonder Valley, so not so great there anymore. But yeah, you have to drive east. Drive east through Wonder Valley, and then you can hit some really dark skies. Hey, Mr. Page Player. Good evening. So again, we're doing the Ghost of Cassiopeia. This star right here is Gamma Cassiopeia, or Navi, which is the very middle star in the constellation of Cassiopeia, the lazy W. So these are 2 nebulae that are right next to it, right next to the Navi, and they're being powered by Navi. This one I believe is in front, and this one is behind Navi, and so this one's closer to us, and they're both being irradiated and bombarded by this star's amazing, powerful amount of light. Both pretty cool. Both pretty cool nebulae. Cool, 11 thumbs up. I'm at double digits for thumbs up. That means I must be doing something right. Thank you, everybody. I think we'll do maybe another sub or so on this, and then we'll move on to the next thing. And as always, you know, if there's anything you want to see tonight, and it's in a decent place for me to view it this evening, we'll look at it. So don't be shy about suggesting stuff. Michael has suggested a galaxy for later this evening because of its position. It's got to rise for a while, so we'll get to it later this evening, probably one of the last objects. But if anybody has anything they want to see, let me know. There's the 13th sub coming in here. Just a second. Takes a little time to land. There we go. Finally landed. Some pretty nebulae and a big blazing bright star. Okay. What's the next object I picked on here? There we go. Another star cluster, the lawnmower cluster. Alright, let's get this one stopped. We'll go check out the lawnmower. It seems to me, if I remember correctly, this one is kind of a threefer. We can get 3 clusters in one in this. Yeah. Okay. So we kind of got 3 NGC clusters going on in this one. Yeah, 1, 2, and 3 right there. So they are all in there. Let's get you settled in here. And get you plate solved. Yeah, you're pretty close. So we're going to take a look at all 3 clusters. And I'm also going to cut the exposure time in half, because with star clusters it doesn't take much time. In fact, I'm going to cut it in a quarter. Which means I'm going to want to do this. Here. Whoa. Boy, this thing is being very laggy. Very laggy tonight. Jumping all over the place. Back you off a wee bit here. There we go. That's looking a little better. There's those 3 clusters. There's those 3 clusters right there. So let's see what we can see about this. 663, NGC 663. NGC 663. There we are. Just before we get to that, somebody asked me a question. Yes, well, what's the telescope diameter? And you know what? Let me show it again. I showed it at the very beginning, but there have been a number of people here since then who've showed up. So this is my telescope. This is an 8-inch Celestron Schmidt-Cassegrain telescope, often just shortened to C8. So it's an 8-inch telescope, catadioptric, and it's got a Hyperstar, Starzona Hyperstar in the front of it, with a camera stuck in the front of that. So it's an f10 native telescope that with the Hyperstar is running at f1.9, which means it collects light about 25 times faster than the native f10 focal length. And it's all running on an AM5 strain wave mount that's mounted on top of my spare no expense cinder block pier, which lives outside, and the mount and the scope and everything else goes inside. But this stays out here on my pad. And this is all glued together with construction adhesive, but it's not glued to the pad. So I can take a 2-wheel dolly and move it around if I ever need to. But that's what's bringing us the pictures tonight. back to, and good question, thank you for asking it. This is, so the central object, which is NGC 663, this cluster here. It's a young open cluster. It has an estimated 400 member stars and spans about 1/4 of a degree across the sky. It can reportedly be detected with the unaided eye, although a telescope is recommended for best viewing. The brightest members of the clusters can be viewed with binoculars. It is located about 2,100 parsecs, or a little under 7,000 light years away. Its estimated age is 20 to 25 million years, which is, in terms of the life of a star, 25 million years is very young. This means that stars of spectral class B2 or higher are reaching the end of their main sequence lifespan. The cluster appears to be located in front of a molecular cloud, although the two are not physically associated. The cloud has the effect of blocking background stars from the visual image of the cluster as it lies at a distance of 300 parsecs. Okay. Is the mount bolted somehow to the cinder block? Yes, Michael, it is. Basically, I have a hole drilled up through the bottom of this, and then I have a 3/8/16 eye bolt, big eye bolt, with fender washer and a couple of layers of bicycle tube as gasket rubber, and it just screws up into the bottom and tightens right up into the bottom of the mount to secure it to the mount. And then I just unscrew the eye bolt and leave that here when I take everything inside. So yes, it does screw to the cinder block using just a poor man's, I don't know, whatever you call that, mounting system, I guess. Okay. These are three nice little clusters. There's nothing between the cinder block and the mount. That's solid. But when I screw up from the bottom, there's between the fender washer and the concrete, there's just a couple of squares I cut out of a bicycle tube. Because I use fat tire bikes here. Okay. Alright, and I'm realizing I need to go check on my tea is probably boiling. I'll be right back. Star clusters. It might be a little overstretched though. Oh, no wonder. The histogram moved on me. No wonder it looks a little overstretched. There, that's better. The histogram went and done moved on me. Again, some pretty nice star cluster in here. Star colors, excuse me. Got some very orangey stars here, and some which are indicated older, cooler star, and some blue-white stars, which indicate younger and a lot higher energy. Alright, well, let's go take a look at our first galaxy of the evening. What is this one? Another reflection nebula. Which reflection nebula is that? I don't know, maybe we should go look at it, see which one it is. Alright, 3 pretty little clusters there. And we'll move on and check out that reflection nebula, because I'm not sure which one this is. It looks like it's decent size. Alright. Again, we don't seem to really have any image on it. That's probably fine. Didn't move that far. Start the stacking up here. Oh, I should restart this though. At least relax this a bit. Fortunately, I don't think there's VDB 15, probably not going to be much of any write-up on this. VDB 15. No, I don't think it has any. Oh, actually, no, VDB 15. It has VDB 1. Doesn't have a VDB 15. Yeah, I think it's all right around this star down here. I thinky. Alright, let's balance that, and then we'll balance this and see if we can bring it out. It's a decent size, but it may just be, again, a little too faint for us to be able to tackle. Yeah, you can see it around here. Definitely see it around here, even kind of extending out this way a little bit. It's faint and wispy, but it is there. This is... my battery's running low, huh? Well, I know how to fix that. Alright. Shoot, that got rid of everything. Okay. Bad timing on that. Alright. Gotta wait another minute for it to show up. Alright. we are. Stars are still a little oblong-y, but it's alright. We'll get a few subs on this and see how well it comes in. Fortunately, I don't have any information on this. LBN 682. Let's see if it knows what LBN is. LBN 682. Nope. Nope. The E nebula. No, this isn't the E nebula. Did I say 682? Yeah. Let's see if anybody else says 682 anywhere. No, nothing. Nothing. Okay. Well, it was a long shot. What we're going to look at next is a galaxy, actually. At the moment, we're looking at reflection nebula, which are basically our nebulae that are reflecting starlight. I need to brighten this up so you guys can see it. But I think now you'll be able to see it much better. So tonight we've looked at kind of all three kinds of nebulae. The reflection nebula, and the emission nebula, and the dark nebula. And this one looks like it's going to be mostly reflection. You can see it's around the star, and it's pretty bluish in and around close to the star, and then it gets sort of more brownish or tannish as it gets further away from the star. Yeah, I wasn't actually talking, Michael. I had myself muted. We're just kind of filling, waiting for this to fill in a little bit. I'll probably go to 10 minutes on this. And you can see as we're... but thank you for speaking up. You know, sometimes I am babbling away here and don't even realize I've muted my mic. Forgot to unmute it. So thank you for being on the ball. In this case, it was me just kind of sitting here enjoying the evening. So, but you can see as we get more subs in, things are beginning to brighten, and a little bit more structure shows up in the object. Be able to brighten it here in a second again once it, yeah. So, yeah, we're getting a lot more of the structure. Some interesting stuff showing up in here in the browner areas. But this is all pretty much emission or reflection nebula. And of course, the more time I give it, the better it would get. But we got other things to see. And this wasn't even actually on my list. I just happened to notice it nearby and decided I wanted to take a look at it. So here we are. It's not a real bright one, but it's pretty. It does have some structure in it. In fact, we can zoom in a bit here. We got some dark nebula structure up here, some other nebula blocking some of the light here. So, kind of interesting looking nebula. But we'll finish up this sub and then we'll move on to our first galaxy of the evening, which is up here. Yeah, here, Silver Sliver. Although, actually, I might have lied. What is this? Oh, the embryo. Well, I might wait till that goes across. Well, it's either get the embryo right now before it crosses. I think I will. I think we'll get the embryo nebula next. Alright, well there's 10 minutes on. I don't think there is a cluster associated with this one, Mike. I think it's just this one star that's illuminating all of this. Illuminating and irradiating. Let's go take a look at the embryo. I'd say real quick, but it won't be. This is an interesting mixed nebula. Yeah, and then we can hit Silver Sliver after this. It's definitely a different looking. Did I get that in there? Yes, I did. Whoop, whoop, whoop. No, not there. There. It's an interesting looking nebula. Again, of mixed. Again, it's a bit mixed because it's a mixture of emission and reflection. So it's a very interesting looking thing. Time to turn the jacket up a little. Now, has my tea cooled enough yet for me to drink it? Yeah, I think it's getting there. Alright. This will be the Embryo Nebula. Yeah. This one will be brighter in parts, whoa, than what we've been looking at, and dimmer in parts too. Let's back off the stretch a bit. Yeah, it's a bit of a small one, but it's got all three kinds of nebulosity again. You can already see the dark patches in some of this. Oh yes, Michael, tea is, you know, or any warm beverage when you're out sitting amongst the cold stars. It's nice having a warm beverage of some kind. You know, pick your poison. Tea, hot toddies, whatever. But warm milk, well, that might put you to sleep. But yeah, it's great being able to have something warm going in you when it's so cold. Alright, this one again will take a little bit of time, but it's got some really interesting areas up in here that are dark in color. But let's 1333. Let's go ahead and take a look at that. See what Wikipedia has on that baby. 1333. It's a reflection nebula located in Perseus. It was first discovered by German astronomer Edward Schoenfeld in 1855. The nebula is visible as a hazy patch in a small telescope, while a larger aperture will show a pair of dark nebulae associated with Barnard 1 and 2. It is associated with a dark cloud, Barnard 205. Estimates of the distance of this nebula range from 980 to 1140 light years. So, somewhere in the 1,000 to 1,100 range for this. Oh my goodness. They've got James Webb Space Telescope images of this up. Holy moly. That's not what we'll see. But they've got some of those images up here. That's, wow, it's amazing. The nebula is in the western part of the Perseus molecular cloud. It's a young region of very active star formation, being one of the best studied objects of its type. It contains a fairly typical hierarchy of star clusters that are still embedded in the molecular cloud in which they formed, which are split into two main subgroups to the north and south. Most of the infrared emission is happening in the southern part of the nebula. The nebula region has a combined mass of approximately 450 million solar masses, while the cluster contains around 150 stars with a median age of 1 million years. Wow, that's really young. And a combined mass of 100 million solar masses. The average star formation rate is, well, it doesn't mean anything. Within the nebula are 20 young stellar objects producing outflows, including Herbig-Haro objects, and a total of 95 X-ray sources. So, definitely an area of star formation here. Mr. Page, sorry if it was asked briefly, but what focuser are you using and what is your process after? My focuser is the focuser on the back. I do not use motorized focusers. I do not use autofocusers. I just use a Batinov mask and I focus it. And I rarely have to focus again during the night. as you can tell from the picture of this, I have it reflectix wrapped, which helps dramatically with preventing heat flows inside, or heat boundaries, boundary layers of air moving around in here as the primary mirror cools and the outside mirror cools, the outside corrector cools. And so this really helps stabilize the air inside the scope by insulating it, not letting it cool inside so quickly. So that helps a lot with not needing to refocus during a session. And I set it out a couple of hours beforehand, so it is able to acclimate before I ever set it up. So I just come out at the beginning of a session and I use the Batinov mask to focus, and then that's really all I do. I don't worry about. As I said, I have never. It's been pretty rare that I've had to refocus in the middle of a session, even when I've gone 3 or 4 hours. So I don't really have issues with needing to focus or needing to autofocus or do any of that sort of stuff during an evening. It stays pretty stable. That feels so good going in. Nice warm beverage. So, an area of star formation, and I think we can stretch it a bit more because it's still kind of dark for you guys out there. So let's stretch it. Start to get more data in, we can stretch things more. Still looks pretty dark. Okay. I have to wait about 30 seconds for the image to update on my monitoring. Or I can see what you guys are seeing. So far I've had this a bit too dark. So get better. That probably overdid it. We'll see. This is kind of subtle stuff, especially the stuff up here at the top. It's very dim, but yeah, actually that wasn't too much. Okay, good. I can't really tell from this end sometimes. It looks like I've got it way overstretched and blown out, but the reality is the lossiness of the broadcast, the algorithms that are used, and the compression and all that to bring you the show. They're so lossy, it darkens things a lot. So. But now that I've stretched it sufficiently, you guys get a much better idea of the dark nebula regions that are surrounding all of this, and the reflection nebula, of course, is all there nice and big and bright, and we're even starting to get some structure in it, some structure in the cloud. And then up here we've got areas of darker emission that are occurring, but this is a pretty cool area too. And this is the Embryo Nebula. Radio Nebula. For those who know SharpCap and know to look up here, I'll put the... Try and remember to put the target name up there and keep it updated. Let's see what the temperature is. It's not too cold tonight. Yeah, it's 38 right now. A nice, calm, clear 38. So, pretty comfortable. The cold doesn't bother me really that much, especially with the heated apparel. It's the wind. When it starts getting breezy, it makes the temperatures feel so much colder when you've got a wind blowing on you. But tonight it's beautifully calm, which is wonderful. Just start to see some of this darker stuff up here starting to form. These little darker pockets of red gases and stuff that sort of poke out from behind the dark nebula that's in here. Because there's actually another whole section that's in here that's takes a lot of time, honestly, to bring it out. More time than we're going to want to spend. But it's a very interesting looking nebula, both with the reflection part and then the emission part that's up here. It's a really interesting looking one. And I've got to make sure that I stay away from that meridian. Good. Alright, now our next object is going to be a galaxy. And we've got another one down here too. Oh, this is the Robin's Egg Nebula. This is a planetary nebula. This will be an interesting one to see. That'll be fun. Okay. Because it is so subtle, we're going to give this one a few extra minutes to cook. But it is a really pretty one. Okay. So it won't be about good for the embryo. Let's go to our first galaxy. Silver Sliver. Yes. Okay. And we'll head over to that one. Okay. Get set on that. This is a really nice looking galaxy. Yeah, it's right in there. And it is NGC 891 for those following at home. Also called the Silver Sliver Galaxy, and the Outer Limits Galaxy is an edge-on unbarred spiral galaxy. It's about 30 million light years away. Discovered by Caroline's brother, William Herschel, on October 6th of 1784. There we are. Beautiful edge-on. Beautiful edge-on galaxy, and as you can already tell, it's not the only galaxy in the image. There's a few other in there. There's another nice little edge-on spiral right there next to it. And let's bring this in. Yeah, that's about right. It was discovered by, it's a member of the NGC 1023 group of galaxies in the local supercluster. The object is visible in small to moderate-sized telescopes as a faint elongated smear of light, with a dust lane visible in larger apertures. NGC 891 looks as the Milky Way would look like when viewed edge-on. Some astronomers have even noted how similar to NGC 891 our galaxy looks as seen from the southern hemisphere. And in fact, both galaxies are considered very similar in terms of luminosity and size. Studies of the dynamics of its molecular hydrogen have also proven the likely presence of a central bar. Despite this, recent high-resolution images of its dusty disk show unusual filamentary patterns. These patterns are extending into the halo of the galaxy away from its galactic disk. Scientists presume that supernova explosions cause this interstellar dust to be thrown out of the galactic disk toward the halo. It may also be possible that the light pressure from surrounding stars causes this phenomenon. 30 million light years away. Yeah, this little guy's pretty cool down here. We keep him in the view for reference. Wonder how little baby it is. Let's see what the annotation tells us. Well, it has an NGC number on it. 898. Boy, look at all the galaxies in here, huh? Quite a few. Anyway, this is NGC 898. Let's see if we can see how far away that is. NGC 898. We know this one's 30 million away. Let's see. Ooh, does not have an entry. NGC 898 does not qualify for an entry. That's unusual. That is unusual because usually pretty much most things in the NGC catalog have a little bit of a write-up in Wikipedia. This one does not seem to. There is an even smaller one just barely touching the lower right of the main galaxy if you zoom in. Oh, I see. You're saying there's one in here too. I see. All right. Well, then we will zoom in here in a little bit, as soon as I've gathered a few more subs. Well, I don't know, this seems like a bit of a fuzzy patch that doesn't seem to be very star-like, but it doesn't seem to be very galaxy-like either. Yeah, I'm not seeing anything. Chances are it's not going to be, it's going to be too faint. Anyway, my galaxies only go to, my catalogs only go to Mag 18. So, if there is one there, it's, if there is one there, it is, going to be fainter than that, so probably not included in my loaded catalogs anyways. So that is it, huh? This right here is an actual galaxy. Interesting. Well, certainly this dust lane is pretty cool. SRB 2001 asks, why are online images of the Sliver Galaxy flipped left-right compared to this live view? Well, depending on the type of telescope that is being used, some optics flip images, some optics invert images, and some optics do both. In my case, it definitely does flip it, or I guess invert it. So it's upside down to the way most people view it, or some people view it. With the way the SCT and the Hyperstar interact together, it flips it upside down, and possibly even left to right as well. I'm not sure. But it's like, which way is right? You know, it's space. There is no up and down, so depending on who's doing the images and what optical train they're using, the object may look oriented completely differently. And if you're doing it from the southern hemisphere, again, it looks, upside down. So depending on who's looking at it, who's doing it, the same object can look quite different from one telescope or optical train to another. So hopefully that answers your question. Okay, so we're going to do the robin's egg next. I think that should still be plenty high enough, which is our only planetary nebula of the night. But this is a pretty cool galaxy, 89NGC 891, or the Silver Sliver Galaxy. So let's go look at the robin's egg, which is all the way down here. It's low, but it should be. Looks like it's still in a pretty good spot though. Okay, let's plate solve that. ZOAG G140.39-17.38. Good Lord. Everybody knows that. Okay, so now do this. Get this started. Now usually planetary nebulae are not very dim. They're usually pretty bright, but they're also usually pretty small. So size. Yeah, 6 arc minutes. That's actually a pretty decent size. So let's see what we can see on this. Okay, sorry that I disappeared on you for a few minutes there. I actually had some friends show up here in real life and asked me what was going on. So now I get to tell you what I told them, and this is the Robin's Egg planetary nebula. So this is basically the death process of a star, a main sequence star, much like our own. And as a star gets really old, which ours will do in about 4.5 billion years, it's burned off a lot of its fuel, and it starts expanding. It loses gravity, it loses density because it's burned a lot of its fuel off, and it starts expanding, and the outer layers of the star just start drifting off, and the star itself, the core of the star, stays. It continues burning. It's just a lot smaller and dimmer than it used to be, but it's enough to be able to illuminate and irradiate the layers of gases that the star is sloughing off. So you see this object that is now many times bigger, many hundreds of thousands of times bigger than it used to be, because the core of it is actually illuminating and irradiating the gases that it is sloughing off. So and they can be all different kinds of shapes and sizes, depending on the magnetic field of the star that's emitting it, depending on the gravitic, influences of the solar system, if any, that's around the star, around neighboring stars and planetary systems. Planetary nebulae can be all kinds of wild and crazy shapes. Most of them are spherical or somewhat spherical, and in this case, it's kind of oval in shape. But and this may or may not be the central star it's coming from. I think it might not be, given how bright it still is. But yeah, this is a planetary nebula. It's a Robin's Egg. You can see why, because of the color and the shape. It's called the Robin's Egg Nebula. In fact, I should write that up here. Robin's Egg. And it is. It's a very intense blue. It's a pretty object. Love the color. Let's see what else. Okay, we got another object. Okay, we got the witch head now crossing the meridian coming at us. I might not have to even flip over the meridian. If we time all this right, might be able to just stay here and see. I did these two already. Now those three. Did that one. Now M81, 82, C3, and Michael's Galaxy are still on the rise, so I'll probably have to flip them over to meridian to do that. But the rest of the stuff I could probably just wait for, and it will come to us. I've got the witch head coming over here. We're going to do M42 because I haven't done that one. I haven't done that one in a while. Yeah. So okay, good. The witch head is already crossed. The witch head is a very It's a very cool one, but it's a very faint one. It's a full reflection nebula, but it's a faint one. So we're going to spend a little time on that one. This one's much more bright and intense. You can almost see some structure in there. Michael says, now I know why I've never seen that. It's all the way down at 4 too low for my scope. Yeah. Yeah, it's probably only about 20 degrees up off of my horizon. What do we got here? These 10s? Yeah, that's 10 degrees, so... yeah, 10, 20... Yeah, about 25 degrees up right now. Well, given that it's over here, probably about 20 degrees now. Less than 20 degrees. But... Mr. Yowza. Hi, Mark. I thought you had already subscribed to me before. Well, we're doing an object that you could see from your neck of the woods, the robin's egg. How warm is it down there right now? Mark is down in Queensland, Australia, kind of central, way inland, and it's very hot down there right now. We're all midwinter, they're all midsummer, and usually doesn't experience days under 40 degrees C very much this time of year. So his temperatures are pretty similar to mine here in the Mojave Desert, except he gets a lot more humidity than I do. Yeah, he's at 43. Yeah. So what's that, about 108? 109, I'm guessing? Let's see, I've got my handy dandy. 43, that's about, yeah, it's about 110, actually. Yeah, with humidity probably too. No, thank you. I'll take my dry heat. Oh yes, and Mark, Don is also here. Is anybody broadcasting on NSN tonight? Oh yeah, Door Peninsula is, that's right. I guess they're the only ones. I'm surprised Mark Bahu didn't come on tonight, because he should be in the clear. If I'm in the clear, he should be in the clear. But who knows? He's so close to the marine layer that he can get messed up. Anyway, I think that's a pretty good go on the robin's egg. 22% humidity. Well, that's not too bad. But still, at 110 degrees, that's yikes. Alright, robin's egg. We got that one done. Now we're going to go to the witch head. And the witch head is a much more faint object, but it's a really pretty reflection nebula. And we're going to go get the upper part, which is the brightest part. And it's probably pretty close. Yeah, I think we're going to do about like that. That will do us. It's a very faint reflection nebula that's coming off of Orion, right next to Orion. Okay. And the big, kick-ass, huge, supergiant Rigel is the one that's illuminating all of it. And Rigel is the bright star at the bottom right corner of Orion. Oh, I need to plate solve. Make sure I'm on the target. Yeah, it was off by a little. So that big bright star is illuminating all of this and making it all glow. So we're going to check that out now. Well, Mark, now you can subscribe to me and you'll know I'll be easy to find for you then, whenever I'm doing these. Usually I broadcast on Night Skies Network, but YouTube is good too. YouTube gets a broader audience of folks. So I like coming here to YouTube too, but Night Skies Network is kind of where I mostly broadcast. Although one of the nice things about being there is you can actually live chat with everybody right on the broadcast. It's not listening to one person while everybody else types their chat in. You can actually talk live. Everybody can talk live if you have a microphone, or you can just choose to listen only, or you can just choose to text chat if you want. So it's kind of cool. But having the freedom to be able to do that is nice. All right, so we got a bit of it already showing up here with the first sub. In fact, I might overstretch it a little bit just so you can see it a little bit better early on. But as we get more subs in, it will be it'll become brighter and brighter. But again, Rigel is the bright star Rigel in Orion is the one that is making all this, well, it's all this providing all the light that's making this reflect. In fact, I'll overstretch it a little more here. Really brighten it up, and we'll let it clean up with more. Oh, well, thanks for being here, Michael. Yeah, I will definitely get to your galaxy later on. Sorry you didn't get to hang for it, but yeah, I can understand it's a bit late for you on the East Coast. So good night, and I'll see you next time. Thanks for being here. Almost all my family is back on the East Coast. In fact, right now, all of them are back on the East Coast. So they always have to watch it the next day or whenever. So it's a little late for them. Especially in the summertime when I can only start at, 9:30 or 10 o'clock Pacific. It's well after midnight East Coast. And Wikipedia has some stuff on this. IC 2118, also known as Witchhead Nebula, is an extremely faint reflection nebula believed to be an ancient supernova remnant or gas cloud illuminated or gas cloud, illuminated by nearby supergiant star Rigel in the constellation Orion. It's about 900 light years away from Earth. The nature of the dust particles reflecting blue light better than red is a factor in giving the Witch Head its blue color. Radio observations show substantial carbon monoxide emission throughout parts of the nebula, an indication of the presence of molecular clouds and star formation in the nebula. In fact, candidates for pre-main sequence stars and some classic T Tauri stars have been found deep within the nebula. So this is a stellar nursery. Huh. Molecular clouds are probably juxtaposed to the outer boundaries of the vast Orion Eridanus bubble, a giant supershell of molecular hydrogen blown by the high-mass stars of the Orion OB1 association. As the supershell expands into the interstellar medium, the favorable circumstances for star formation occur. The Witch Head is located in one such area. The wind-blown appearance and cometary shape of the bright reflection nebula is highly suggestive of a strong association with the high-mass luminous stars of Orion OB1. The fact that the heads of the cometary clouds of IC29 point north of the Witch Head point northeast towards the association is strong support of that relationship. So, like I said, Rigel is driving the light from all of this sucker, and it's making all this glow. But the whole Orion area is just a massive area of clouds of gas and dust and lots of star formation. What we'll look at next, M42, is one of the biggest, brightest areas of that star formation. So not just a pretty face. The Witch Head face? Who are you calling pretty? Right now I'm loving a snack, so that's why I'm muted. Yeah. I am loving the Hyperstar too. The speed works with my dark skies really, really well. So, you know, when I had my Newt started at F4, that was great. Then I got the Nexus. Reducer coma corrector and went to F3, and that was even better. And then I got this, the Hyperstar, and it's even way better again. So the faster I go, the better it seems to get, at least for my skies. So it works really well. Working good for me too. And it's not a very expensive setup to do, you know. The Hyperstar is the most expensive part. If you wait and check the classifieds in the used market, you can get them for 70, 80 cents on the dollar, so it's not real expensive either, relatively speaking, to go this fast. But it's working really well for me. Some pretty dust clouds. We're going to go from here to something much brighter. Ooh, and it has crossed the meridian just now. That's perfect timing. So we'll give the Witch Hat another couple of minutes, and then we'll go to the big, bright, shiny object in the winter sky, which is M42, or the Orion Nebula. Which is actually a very difficult target to get well, because it's a very, very large dynamic range with it. Very bright spots, very dim spots. It's hard to do well. So I usually don't. But it's still pretty to look at. Still very pretty to look at. This is a bit mono-colored, but it's still got a lot of pretty structure and detail in it. Just lots of cool stuff going on. This is the top of the Witch's Hat. Again, I'm upside down here because that's what my optics do. The Hyperstar kind of flips everything upside down. But and 15 minutes, that's pretty good. Lots of pretty cloud. Had my last night with the comet last night. Yeah, you took a number of really cool images of that, so that's pretty darn cool. All right. Good night, Witchhead. Let's go to the big show here and make sure we can get all of this. I think that's going to be about right. Let's go pop up here, actually just a little bit higher, so I can make sure to get all of Running Man nice and clear, and the coal car cluster and all that stuff. Okay. There we are. Get on in there, you. Settle out. Dead on. Good deal. In fact, you know, here we've been talking about how everything's upside down. Before I start, I'll actually flip it. Yeah, there we go. That's the way everybody's used to seeing it. Although, what happens if I do both? What happens if I do both? Yeah, I guess both is the way that people are used to seeing it. So let's do the both. Okay. And this. And as I said, this is a tough one to do because there's such a huge dynamic range to it. There's just a lot of really bright and then a lot of really faint and wispy at the outer edges. So you can get all the nice big faint and wispy, but the core is all completely blown out. Or you can cut way back and get the core more managed, and then you can't see any of the stuff on the outside. So it's kind of one way or the other deal. Okay. 42. And there we are. Okay. Sharpen that up a little bit. Bring this way in. Yeah. See what I mean? When you brighten it up, you get all this beautiful wispy stuff on the outer edges, but you completely blow out the core. And here's the other thing we have to deal with a lot in this region, and that is geostationary satellites. Because of my 36-degree latitude, a lot of stuff goes through Orion. A lot of the geostationary satellites in the southern sky go through Orion, so it end up deleting a lot of subs and skipping a lot of subs, and while you let satellites pass through. So sometimes this can take a minute to get good captures here. But this is basically the 3 stars of Orion's belt. Running Man, the coal car cluster, and then M42, and then M43, which is down below. You can see a lot of the nice faint wispy stuff. in here. But then you lose a lot of the core. But this is a very big area of star formation. Big area of star formation. But let's see what Wikipedia has to say about it. A diffuse nebula situated just south of Orion's belt in the constellation of Orion is known as the middle star in the sword of Orion. It is one of the brightest nebulae and is visible to the naked eye in the night sky with an apparent magnitude of 4.0. It's about 1,350 light years away, and it's the closest region of massive star formation to Earth. It's estimated to be 25 light years across, so its apparent size from Earth is approximately 1 degree. It has a mass of about 2,000 times that of the Sun. Older texts frequently refer to the Great Orion Nebula as the Great Nebula in Orion or the Great Orion Nebula. The Orion Nebula is one of the most scrutinized and photographed objects in the night sky and is among the most intensely studied celestial features. It's revealed a lot about how stars are born and planetary systems are formed, etc. Scientists have directly observed protoplanetary disks and brown dwarfs within the nebula. Intense and turbulent motions of the gas and the photoionizing effects of massive stars nearby in the nebula. It's visible with the naked eye as it is the middle star in the sword of Orion, which are the 3 stars vertically located south of Orion's belt. The star appears fuzzy to sharp-eyed observers, and the nebulosity is obvious through binoculars or a small telescope. The Orion Nebula contains a very young open cluster known as the trapezium, due to the asterism of its primary 4 stars within a diameter of 1.5 light years. 2 of these can be resolved into their component binary systems on nights with good seeing, giving a total of 6 stars. The stars of the trapezium cluster, along with many other stars, are still in their early years. The trapezium is a component of the much larger Orion Nebula cluster, an association of about 2,800 stars within a diameter of 20 light years. 2,800 stars within a diameter of 20 light years. That would be a bright region of space. So that makes a nice color contrast with the running man over here too. Well, we're a little bit clipped here. Back that out. See, we've got a satellite buzzing through here. And it's very faint, so we'll leave it. It's very faint, so we'll leave it. But see what happens if I stretch this to really look at the outer wispy stuff that goes out, extends quite a ways past the inner parts. And these even connect a little bit when you really see the outer stuff a lot. But then the core just gets completely blown out. Still pretty though. much time I've got before the next thing comes across. Where is the next thing? What else have I got to look at in here? Oh, the next one is up here. Still got like half an hour to wait for that thing. What else have I got left in this list? Looks like I got that there. Oh, and then we've got these targets up in the north. Yeah, the galaxies. Okay. So that's going to require a meridian flip anyway. So I think we'll do a couple of more minutes on this. This does not need a lot of time, obviously, especially at my speed. It comes in pretty darn quick. In fact, I may just go up and do the galaxy cluster up there. Think of those galaxies and call it a night. I don't think. What have I got in here? I see 2169. What is 2169? Oh, dryers. Yeah, that's a. Oh, we could skip that one. It's another reflection nebula. It's a nice reflection nebula, but we can skip that for this time. We'll go up and do the galaxies that I have left, and that should be pretty well fill out. That'll be at least 3 hours, so that'll fill out my night pretty well. Finish with some galaxies. Yeah, we'll just do 10 minutes. 10 minutes will work on this big, bright, beautiful thing. Very cool. Okay, so if I'm going to do that, then let's go see what am I going to do next. Well, I guess I'll do 81 and 82 first. And we'll make sure we get them both, and we do. So, yeah. 81 and 82. A couple of cool galaxies. That's not what I was trying to do. Okay. Let's do a meridian flip. Head on over to the other side. Okay. Where are you? Are you a little marker? There you are. Why are you way over there, I wonder? Huh. I don't know. Well, there the galaxies are, so not too far off. We got the galaxies in the field of view. Now, this is now going to send me way off to nowhere land. Duh. And now we just re-slew. Yeah, I don't know why it went over there. Yeah. There we go. Get back in there where you belong, you. And there they are. Okay. Go. Collect those photons. After after we get this first sub, I'm going to have to run inside and get my spare battery, because this one's been going for 2.5 hours and ready for a battery replenishment. In my jacket, that is. Love my heated apparel. So nice doing astronomy in the wintertime with heated jacket and pants. And I'm really glad I decided to buy an extra battery when I bought them, because batteries never seem to last quite as long as they say they're going to. Oh, look at you two beauties. Alright, balance the colors up here. Boy, that's just about perfect right out of the gate. Just about perfect right out of the gate. M81 is so pretty. M82 is as well, but it requires a different histogram approach. You know, this one needs to be stretched harder to get all the beautiful outside wispiness, although it does blow the core out a little bit. But then you want to reduce the stretch for 82, the cigar, because it's got a whole inner core, red color inner core thing going on. What are we at here? Yeah, that's where we should be. Yeah, it's starting to catch a little blue out here. Star forming regions. Cool. Alright, well, I'm going to let this cook for a couple of minutes while I run inside and get my fresh battery. I'll be right back. Okay. It's done pretty good. We also start to pick up some other things in here. Another little satellite galaxy, I think. Yeah. I think that is a satellite galaxy of M81. What? Tiny little one in there, huh? There's a few galaxies in here. Yeah, I like M81. It's such a pretty galaxy. Such wispy, fine little outer edges. I guess I should be telling you guys a little bit about these, huh? Messier 81. Okay. Bode's galaxy is a grand design spiral galaxy about 12 million light years away, so in galactic terms, pretty darn close to us. It has a diameter of 96,000 light years, so only about 15% smaller than the Milky Way. Because of its relative proximity to the Milky Way, its large size and active galactic nucleus, which harbors a 70 million solar mass supermassive black hole. 70 million solar mass supermassive black hole. Messier 81 has been studied extensively by professional astronomers. The galaxy's large size and relative high brightness also makes it a popular target for amateur astronomers. In late February 2022, astronomers reported that M81 may be the source of a repeating fast radio burst. Okay, Messier 81 was first discovered by Johann Eilert Bode on 31 December 1774. Thus, it is sometimes referred to as Bode's galaxy. In 1779, Pierre Marchand and Charles Messier re-identified Bode's object, hence listed it in the Messier catalog, where it has the number of 81. Let's see what else. Its apparent magnitude due to season means it requires a good night sky. It only rises very briefly and extremely low at its southernmost limit from Earth's surface, about the 20th parallel south. Messier 81 and 82 are considered ideal for viewing using binoculars and small telescopes. The two objects are generally not observable to the unaided eye, although highly experienced amateur astronomers may be able to see M81 under exceptional observing conditions with a very faint sky. Telescopes with apertures of 8 inches or larger are needed to distinguish structures in the galaxy. We've certainly can see some structure here. The galaxy is best observed during April. Okay. Got somebody running around on a quad out here. Interstellar dust. M81 is estimated to have about 250 globular clusters. Okay. Cool. Well, that's M81, which is this pretty thing here. M82 is this guy over here. So, since we're going to look at that one, let's de-stretch a bit and see if we can pick up some of the detail in it. It means going much lower on the stretch, maybe even zooming in to some degree, but you can start to see some of the stuff that's in here. We lose a lot of the outer part, but you start to see some of the inner structure. When you back off just a bit more, yeah, see, you start to see some of the, there's more color in here and more structure. And it's actually very reddish when you use certain kind of filters with it. Now I'm running just broadband, so can't really say I've got any filters that are bringing any of that out. But there are even jets that shoot out perpendicular to the disk of the galaxy itself. Don, in fact, who was on this broadcast as a guest, he was doing this last night on Night Skies Network, and really very clearly could see the color, the deep red color that was in the middle. I because I shoot it broadband with no filters, I don't really get a whole lot of color from it, but you can get the idea. There's enough color here that you can see what I'm talking about. So since we've kind of focused in on that, let's see what it has to say. It's a starburst galaxy, also 12 million light years away. It has a diameter of about 41,000 light years, so less than half the size of M81, which we were just looking at, and about a third the size of the Milky Way. However, it's about 5 times more luminous than the Milky Way, and its central region is about 100 times more luminous. The starburst activity is thought to have been triggered by interaction with M81. As one of the closest starburst galaxies to Earth, M82 is the prototypical example of this galaxy type. It was also discovered by Bode in 1774. He described it as a nebulous patch, this one about 3/4 of a degree away from the other, very pale and of elongated shape. In 1779, Pierre Marchand independently rediscovered both objects and reported them to Charles Messier, who added them to his catalogue as items number 81 and 82. M82 was believed to be an irregular galaxy. In 2005, however, 2 symmetric spiral arms were discovered in the near-infrared images. The arms were detected by subtracting an axisymmetric exponential disk from the near-infrared images. Even though the arms were detected in the near-infrared images, they are bluer than the disk. The arms had been missed due to M82's high disk surface brightness. The nearly edge-on view of this galaxy and obscuration by a complex network of dusty filaments in its optical images. These arms emanate from the ends of the near-infrared bar and can be followed for the length of 3 disk scales. Also, there's also evidence of trailing arms. But if you look at some of the Hubble photography, you can see there's a lot of structure in here. There's stuff, in fact, extending beyond this thing. So it's a very interesting galaxy. In fact, it's one of Don's favorite things to image. Probably because he does a much better job at imaging it than I do. I don't seem to be able to get a whole lot of color out of it like he does. But it definitely has some interesting structure going on. I like M81 better just because it's wispy, delicate texture is just so much more obvious to me in the imaging that I do. This one is a much tougher object. But you can kind of even sort of see here some of this extends beyond the disk of the galaxy. Some of the central stuff extends out here beyond it. It's a very curious looking object. Well, let's go back to both here. And you see, in order to see the goodies of this, you lose almost all of that. Grab this back to really see all of the size of this, and this just turns into a white blur. But M81 is just so beautiful. You can see there's quite a bit of blue out here with these starburst regions of high energy. All this blue out here. All the star formation that's occurring in this galaxy as well. They both are, probably because they are close together and interacting with each other, and when galaxies get highly active with each other, they produce lots of stars. I guess it's like galaxy sex or something. I don't know. But when they start interacting, their gravity wells just start creating all kinds of high energy in themselves, and they just start popping stars, new stars, and all kinds of things out. So these two are definitely paired, and have other friends in here too. Like we saw this galaxy. That's probably a satellite galaxy of M81, but they are beautiful. Each in their own unique way, have a lot of beauty going on. Oh, I'm sorry, Mark. That's right. I forgot. We got to clean this up before it heads south of the equator, because we don't want to hear that SEX word. I just got that. Actually, probably YouTube automatically bleeped it out when I said it for you guys down there in the Holy Land. Two beautiful galaxies. Okay, what's next? What did I have next here? I think I picked something else. Oh yeah, M97 and then Caldwell 3. So this is a pretty cool little... Yeah, let's see, how do I want to... they're both about the same. I don't think it matters much. Let's go do M97 and 108. Two things that are nice to do together. M108 is the Surfboard Galaxy, and M97 is the Owl Planetary Nebula. There's one, and there's the other. So we can just go. No need for any... no need for any plate solving, because we're just there. Surfboard Galaxy is another one that's sort of like M82 a little bit. Got some interesting structure in it when you get in there close. But there's the owl, and there is the surfboard. Now let's get this histogram cleaned up, and we'll be able to see him a lot better. There we are. The owl is another planetary nebula, much like the robin's egg. And it's perfectly spherical, except it has some interesting inner structure that we'll look at after we've gotten a few subs in and resolved all the noise and graininess out of it. Okay. Let's see here, 97. Yeah, I never was getting mixed up. 97 and 108, or is it 98, 107? I get it mixed up. Anyway, this is M98, the Owl Nebula. I'm sorry, M97. See, I did it again. M97, the Owl Nebula. It's a planetary nebula just over 2,000 light years away. It's estimated to be about 8,000 years old. It's approximately circular cross-section with a faint internal structure. It was formed from the outflow of material from the stellar wind of a central star as it evolved along the asymptotic giant branch. As it evolved along the asymptotic giant branch, there's a region of the Hartsprung-Russell diagram populated by, so it's a type of star. Period of stellar evolution undertaken by all low to intermediate mass stars. Yeah, so anyway, it's part of the death process is all that all means. The nebula is arranged in 3 concentric shells, with the outer shell being about 20 to 30% larger than the inner. The owl-like appearance of the nebula is the result of an inner shell that is not circular symmetric, but instead forms a barrel-like structure aligned at an angle of 45 degrees to line of sight. So, as we will be able to see once we zoom in a bit more here, there is some dark inner structure in here, and for that we will have to back off a bit on the stretch. Let it darken up a bit, but you can see there is some inner structure in here. Have I imaged it at native focal length? Star Traveler 29 asks, and the answer is no. I actually just got this C8, and I already had a 6.3 reducer, oddly enough. So I put the 6.3 reducer on it. This was before I even got the Hyperstar, before the Hyperstar came available, and so I put the 6.3 reducer on it. Found focus, and basically, found a good enough focus to get it collimated, get the secondary collimated and everything else. And that's the only time I have ever used the back of the scope. Then I eventually found the Hyperstar on the used market, and got the Hyperstar, and put that on the front of it, and have just been loving the Hyperstar so much that I haven't gone to the back of the scope again. So, however, I am going to be doing that, certainly for Galaxy season. So in the next month or so, I will be taking the Hyperstar off and putting the secondary back on, and probably putting the 6.3 reducer in there, and playing with that for a while. And I don't know, will I use native focal length? Could be. Maybe I will when the secondary is in. I'll try using it at f10. Problem is, I just f10, the native focal length is really good for doing things like planetary stuff and solar system objects generally, which I which I don't do. I like DSO. I don't like solar system stuff, so I don't know that I will ever really use it very much at all at the native focal length. I may try and do some moon work every once in a while. That would be kind of fun. 2,000 millimeters of focal length and cruise around the, kind of walk on the moon. So I may play with that someday. But I think I probably will just stick to the 6.3 reducer on the back and the Hyperstar on the front, which obviously can't be done simultaneously. Would be nice if you could, but it can't. And so that would be pretty much how I will use it. So no, I have not done anything, honestly, at native focal length. Nothing at all. So, like I said, in a month or so, I'll put the 6.3 reducer on, and I'll do Galaxy season with the 6.3 reducer. 1,300 millimeters of focal length will be nice to do that. And then maybe, I'll pop over and see this at 1,300 millimeters. Probably get a lot more detail out of it. But, yeah, haven't played with native focal length. Maybe sometime before I do. You can even actually see it here. You're getting some red color. Just a little bit of redishness out here. Just on the very edges. There's a little bit of red. Is there a practical limit for exposure length with most targets for my setup? At the moment, yes. I don't know if you've seen my setup. I showed it a couple of times, but that was early. So basically, I'm just, the C8 with the Hyperstar on an AM5. This is what I'm using, and right now you'll see that I do not have a guide scope or camera on here, and I'm not using an OAG, obviously, with the Hyperstar, so I am going completely unguided. So at this point in time, yes, I do have a practical limit because I'm not using guiding. I can go about 90 seconds with no problems, unguided, and still get nice round stars and good images. When I go to 120 seconds, then the stars start streaking and elongating a little bit. So right now, I would say 90 seconds is my practical limit for exposures, as I am currently set up. Part of my change to the scope when I do go to the 6.3 reducer and start using the longer focal length is I will be putting the guide scope and camera on it. I'll need to have guiding, obviously. When I'm at that focal length, because I'll be doing longer exposures too. With that focal length, I'm going to be needing to be doing longer exposures because it's going to be much slower shooting at f6, 6.5, as opposed to f1.9, which is very fast. Okay, let's try tweaking this a little bit. Problem is, it might blow it out too much for you. So let's see if that looks better. Looks better to you guys. But this is the Surfboard Galaxy, our M108, the 108th object in Charles Messier's list, which is actually one of the objects that was added posthumously to his list. He actually only had 103 objects in his list at the time of his death. And researchers in subsequent years were going through his notes, his observation notes and logs, and discovered that he had actually discovered several other objects, but just hadn't published them and just hadn't updated his catalog with those published objects. And so the objects 104 through 110, which is where his list finally ended up, all showed up after his death. And so this is number 108. This is one of the several that was added from his notes after he passed. And it's called the Surfboard Galaxy. You can kind of see why, not only from its shape, but its kind of cool design, Very interesting looking galaxy. One more thing about the owl. Oops. one more thing about the owl is its central star in here. I guess I will have to unstretch this again. Its central star in here is actually past, what are they saying? The 14th magnitude central star has passed the turning point in its evolution and is condensing to form a white dwarf. It has 55 to 60% of solar mass, is 41 to 148 times solar luminosity. That's pretty big a range. And has an effective temperature of 123,000 Kelvin. The star has been successfully resolved by the Spitzer Space Telescope as a point source that does not show the infrared excess characteristics of a circumstellar disk. So, it's definitely dwindling. It was discovered by Pierre Marchand in 1781. Okay, now we can go back to, no, not that. Let's go back to our surfboard, dude, where we were before, and re-stretch this so we can see that a little better. I'll tell you about M108. Very interesting looking galaxy. 108 Galaxy in Ursa Major. It's a barred spiral about 46 million light years away from Earth, so this is the furthest one we've seen so far tonight. Discovered by Pierre Marchand in 1781, War II. It is seen almost edge-on. The galaxy is an isolated member of the Ursa Major cluster. It has a morphological isolation, blah blah blah. Which means it's a barred spiral with somewhat loosely wound arms. It has a mass of 125 billion solar masses. It has about 350 globular clusters. '83 X-ray sources. The supermassive black hole at the core has an estimated mass of 24 million solar masses, as opposed to the 70 million solar masses of the M81 we were looking at before. So this one is 46 million light years away. So 4 times the distance of M81 and M82 that we were just looking at. I don't know that it says its actual size, though. It gives its angular size, but it doesn't say what that means in terms of its actual size. Parent type, yeah, I don't really see that information. But anyway, it's a pretty cool looking galaxy. Lots of interesting lots of interesting structure in this sucker. It looks like it's just one sort of solid surface, but this is all structure on the going around the outside of the disk. You said it makes live imaging enjoyable. I might be able to set up at my community center for an astronaut. Yeah, it does. I'll be, in fact, taking this down to Death Valley here in a couple of weeks for the Dark Sky Festival, when I'm a member of the Las Vegas Club. And we do the star party for them down there, and I was doing it with my imaging unit at F3 and F4, and that still worked very well, but this just makes it even faster, quicker, faster, and easier. So, yeah, it's a great EA rig. I mean, this speed is just awesome, and under dark skies, and I see you say you're Bortle 3.4, so that's that's pretty good by most standards. That's very good by most standards. Yeah, the speed works. That works really well. So surfboard must be a modern name. Why do you say that? There were surfer dudes hanging out in the 18th century? You kidding me? Riding the waves, getting toasty. They've been around forever, dude. Alright, we'll do one more minute on this, and then we'll head to our last object of the night, which is the object that Michael requested way back at the beginning. But we had to let it rise before we could see it. Alright. The surfboard and the owl. I guess we can take a look at them in full context again. Neighbors that they are to each other. Even though they are 46 million light years apart. They're visual neighbors only because, of course, this planetary nebula is inside the Milky Way, so this is in our galaxy, and this one is in a whole other galaxy 46 million light years away. So, they just look like they're neighbors. They have absolutely don't even know about each other, quite frankly. Anyway, on to other things. No, not you. We've already seen you. Okay. The last object, which was Caldwell 3. The galaxy, no, not that. Click on this. Thank you. Michael's galaxy here. Alright. I'm not seeing it in there, so let's plate show. No, it says it's there. It's either pretty faint or it's either very faint or very small, because I ain't seeing it. Alright. Well, I'm sure we'll see it when they get a first sub in here. Very interesting. 4236. 4236. Let's see. GC 42. 36. Galaxy in the Draco. A barred Magellanic spiral located in Draco. It's approximately 12 million light years away, so like the M81 and M82, it's in the same locale in the same family. And that's all they say about it. That's all they say about it. Parent size, yeah, parent size. yeah, not much else to say about it. A Magellanic barred spiral. Magellanic spiral galaxy is a spiral galaxy with only one spiral arm. Huh. Really? Magellanic spiral galaxies are classified as type SM. The prototype galaxy and namesake is a large Magellanic cloud. They're usually smaller dwarf galaxies. Huh. Okay. One arm. They are the one-armed bandits of the galaxy world. Hey, Eli. How are things in NYC? I think you guys are cloudy tonight, based on some of what your neighbors have told me. Alright, let's see if I can get a little more out of this. Been looking at the ASI 585. How comparable to the 183 do you think it is? Well, that's funny you should ask. I've actually been looking at the 585 too. I have friends who use them and like them. And because I use 183s, in fact, I have two 183s. It's the only camera I have right now. I've had other cameras, but those are the only two I have right now. They seem to just work perfectly for where I'm at the moment. So I have also been comparing the 183s to the 585. Well, in terms of numbers, the 585's field of view is much smaller, well, significantly smaller, because it's a smaller sensor than the 1-inch sensor on the 183. The pixels in the 585 are also larger, so your image scale is larger. So it's smaller field of view and a lower resolution image scale, which for me is 2 thumbs down for that, so 2 not so good things. On the plus side, however, for the 585, it's one of the new Starvis 2 sensors with no amp glow, so you don't need to use darks, which is very nice. You certainly do need to use fairly recent darks with the 183 because they're older, noisier sensors. So that's nice. The other advantage of the 585 is that it has 3 times the full well of the 183. So you get a lot more dynamic range with them. You can take in a lot more light before stars and things start to saturate, which is a very handy thing. So, it has its good and it has its bad. Some things are better, some things are not so much. So, I've considered buying one, but I've pretty much just stayed away. The smaller field of view and the lower resolution is not something that I'm all that interested in. I'll keep my calibration, my good darks and flats going, and not worry about the no amp glow stuff. Obviously the images are grainier with the 183. You can see it in my images. It is a bit grainy. It's not as smooth as a sensor as some of the newer sensors. But yeah. So I have chosen to not go there, just because I think the cons are more significant than the pros. But the 585 does have a couple of nice upsides. So given that I'm primarily going to be using the Hyperstar, a smaller pixeled camera is better for me than a larger pixeled camera. And the 2.9 micron pixels of the 585 are not that much bigger than the 2.4 of the 183. It's not that big of a difference, but it's significant enough for me. I couldn't zoom into objects as much as with the 585 as I can with the 183. But then again, when I zoom in more with the 183, it's grainier looking, so I don't know, maybe I shouldn't be zooming in as much as I do anyhow. But Yeah, so anyway, blah blah blah, kind of rambling along there. But that's kind of the ups and the downs of it for me. I have looked at getting it as well, and I know I have friends who use them with great success, and they're a good camera. They are a good camera. I just don't, for where I'm at, what I'm doing, they don't seem to be a positive selling point for me. So I have stayed away. And what I really want them to come out with is the second, the 183 version 2. I want them to come out with a Starvis 2 version of the 183 sensor with the nice small pixels and the full 1 inch sensor size and all that kind of stuff. That's what I really want them to come out with, but no, I don't know. Not so far. We'll see. So the 183 is still in very widespread use. It's a venerable small pixel camera. You can't find a camera that has pixels this size with a sensor any bigger than this. So it's still very widely used, especially on short focal length optics, like Hyperstar SCTs and short refractors and wide field refractors and scopes, imaging scopes and imaging newts. Things that are more wide field and short focal length. They're hard to beat. So there you go. I have the Player 1 version of the 585. Yeah, I had a Player 1. I had the Aries, which is the Player 1 version of the 533. I also liked it as well. I enjoy that it's sensitive to near IR, allows me to use dual band with sensitive to IR like the DTD IDAS filter. I think for Bortle 8.9. Yeah. Yeah, you could very well be right there. For me, I don't really care so much about the IR, near IR, all that stuff. For me, the most important things are pixel size to focal length, so the image scale that's involved. I like staying around 1.0 if I can. I usually have seeing that can get me in the range of that, not always, but my seeing is usually good enough that I can take advantage of an image scale in the 1 arcsecond per pixel range. Sometimes not, but usually I can. So I like staying in that range, and so for me that's kind of the most important factor, along with field of view, but image scale for me is the most important thing. But having the bigger full well, the 585 has almost 3 times the full well of the 183. That's a pretty big deal. That's a lot more dynamic range and a lot less saturation you're going to get on your images. So that does prevent me from putting the 585 on the back burner entirely. I still do think about it, but just haven't gone there. So hopefully that answers your questions there, Star Traveler. Probably more information than you ever wanted to know, but there it is. I've considered getting one, just to compare how compare what I get from one to the other. Who knows? It may produce better enough image quality that the loss of field of view doesn't mean that much to me, So I thought about trying it. They come up fairly frequently on the used market, so it's not like there'll be a shortage of them anytime soon. But I just haven't. I've been enjoying my 183s enough that I just haven't gone there. As I continue to zoom in again. See, I couldn't. We'd definitely be pixelated with the 585 if I was zoomed in this far. As it is now, I'm not pixelated, but it definitely is grainy. It's the thing about the older sensors is they're definitely a bit noisier and grainier, even well calibrated. 585 might you know, be a bit smoother. I remember my 533s, and I owned both the ZWO and Player One versions of the 533. I believe Player One was called the Aries. I owned them both, and they were, you know, those good sensors, good cameras. Good cameras both, good sensors. The new sensor technology is nice. Not having to deal with darks is nice. The added full well is really nice. You know, 50K full well is pretty nice. So, who knows? Someday I may pick up a 585 just to play with it. See how it compares to the 183. But on paper, at least, me no likey as much. But I've tried other cameras that. Oh yeah, Don. Yeah, Don. Well, there he is. I mean, Don here he runs both of those cameras. He has 183. He runs a 585 regularly too, and produces really good images with both. But they, you know, they both have their pluses and minuses. The color reproduction of the 183 is better. I do get nice color with the 183. I tried a 676 for a couple of long sessions because it has 2 micron pixels. It's a planetary camera, it's uncooled, but and it's a small sensor. It's really designed as a planetary, but you know, it has the new Starvis 2, blah blah blah, no darks needed, no amp glow, 2 micron pixels, so even a finer resolution. And lo and behold, it did not produce the same level of color as the 183. The 183 just does a beautiful job with the color. I mean, even looking at this image, you can see the clear areas of blue, the areas of high energy star formation in this galaxy, where you very clearly the blue is popping out. And with the 676, you just did the colors were much more muted, and so it just didn't do me right. I tried it for several hours of observing with the 676, and just went back to the 183 and sold the 676. It just didn't produce the kind of color. So, like Don says, the 183 does. It's another plus for the 183. The 585 is a little bit wonkier on the colors. I think Don said it has too much red, I think, with the 585. So, yeah. They're both good sensors in their own way, but for my purposes, the 183 is still king. But I may try a 585 at some point. You never know. You never know. It may work out that even though on paper it's not supposed to be that much better, it is anyway. So, well, this galaxy certainly has stood up to needing a little more time, so I'm glad we spent the extra time. It is an interesting galaxy. Tell what's going on. So it looks like it's a barred. It looks like it's got a bar in here, so it looks like a barred spiral. Barred Magellanic spiral. So that's just saying it has one arm. Because that looks like an arm to me. That looks like an arm to me. This looks like an arm to me. So I'm not sure what they're saying. But anyway, it looks to me like it has more than one arm. But their pictures are, I'm sure, a lot better than mine. But definitely you can see some areas of blue star formation in here. I think that's going to be about it for me. I've been going for about 3.5 hours here, and we got through, I think, my whole list, including Michael's bonus object here, VGC 4236, which is an interesting looking galaxy. Needs more time. It's got definitely some faint, wispy parts to it that could probably sit on this thing for half an hour, trying to clean it up and resolve it a bit more. But not going to happen tonight. I think that's going to be it for me. So, thank you everybody for being here. Appreciate you watching, whether you're sitting here live with me tonight or watching in the days and weeks ahead. If you've stuck it out this far, I really appreciate that you were here. So, thanks everybody, and I will see you all next time.